Okay, loose is three types: loose areolar, loose reticular, and loose adipose. So these are three types of loose. Dense, two types: dense regular and dense irregular. Okay. So that is connective tissue proper. Then bones. Bones are two types: compact, which is hard, and spongy, which is soft. Cancellous bone, spongy. So these are two types of bones. Make sense? Okay. Then cartilages. How many types? Three. Hyaline, which is most common. Most common. Elastic and fibrocartilage. So these are three types of cartilage. Hyaline is the most common. Most of the cartilages are hyaline type cartilage. Okay. Elastic, only few structures, and fibro also only few structures. Then fluid type connective tissue includes the blood. Blood is a connective tissue, and lymphatic fluid inside the lymphatic system, lymph. So this is the classification of the connective tissue. This classification is very helpful for both the lecture and the lab. So if you know this, it will be easy to follow the things. Okay. Let's quickly review. Okay. First, connective tissue is divided into what? Connective tissue proper. That's the main type. Bones, cartilages, fluid. Proper could be what? Loose and dense. Loose, three types: areolar, reticular, adipose. Okay. And dense, regular, irregular. Which one has more fibers? Dense. Make sense? That's why it is dense. Fibers are heavily present inside. In loose, you'll see few fibers or almost no fibers. Bones. Hard bones are called compact bones, and spongy, soft. Cartilages, hyaline, elastic, fiber. Okay. Blood and lymphatic fluid belongs to fluid type of connective tissue. Okay. Now you see, blood is completely different than cartilage, right? Cartilages are different than bones. Bones are different than other structures like fat, adipose. But why? All these belong to connective tissue, because the source is same. They are coming from same embryonic tissue. Okay, embryonic tissue, stem cells are there, right? So different types of structures are being formed from that, and that is called mesenchyme. Embryonic tissue gives all kinds of connective tissues. Make sense? Same source, so they belong to same type of tissue, although they are very different from each other. Connective tissue has varying degrees of vascularity. That means, epithelial tissue is what? epithelial tissue has blood vessels or no? Avascular, right? Absence of blood vessels, I mentioned. Connective tissue, some connective tissue has a lot of blood vessels, some connective tissues less blood vessels, some connective tissues no blood vessels. Make sense? How about cartilages? Any blood vessel in cartilage or no? What do you think? No, cartilage doesn't have any blood vessel. That's why if you cut the cartilage, no bleeding. Make sense? Bones have some blood vessels. So when fracture occurs, bleeding occurs. Okay? Adipose tissue or fat has some blood vessels, but less than muscle tissue. Make sense? So you see, and blood itself is a connective tissue. So connective tissue, some connective tissues have no, some have small amount, right, of blood vessels circulation, some have plenty. So varying degrees of vascularity. Another thing, presence of cells and non-living extracellular fibers. You must remember when I did draw the epithelial tissue, every time I showed what? The cells are attached to each other, right? Remember that? But in case of connective tissue, it is rare. What we see, the cells are not attached to each other. These are the cells, and in between the cells, you have the matrix. Okay? In between the cells, you have matrix. Is it clear? And matrix consists of two things: ground substances and fibers. So the matrix composed of the ground substances, the chemicals and fibers. Cells are living, alive, and matrix is non-living. Okay? So connective tissue consists of what? Cells and matrix, right? Cells are what? Alive or dead? You all know that. Cells are alive, right? And matrix non-living. And matrix composed of ground substances and fibers. So you have fibers. Okay. Now, in the connective tissue, three types of fibers are seen. Some connective tissues have no fibers, some have one type of fibers or two or three. What are those fibers? You need to know. Fibers, so fibers could be three types. The most common is collagen fibers. Another type of fibers are called reticular fibers, and then elastic. So these are three types of fibers: collagen, reticular, and elastic. Functions. Connective tissue, why it is called connective tissue? Because it connects. Main function is connects. You know, I mentioned that your bones and cartilages are connective tissue, right? Both are connective tissue, right? Remember that? So you see here, these bones are connected by what? Cartilages. These are cartilages. See? So in different locations, particularly in the joints, cartilages connect the bones. Make sense? So connection is very important function. Ligaments, tendons, those are also connective tissue. They do what? Connect, right? Ligaments connect bone to bone, and tendon connects muscle to bone. So muscle and bone. Muscle to the bone, tendon. One bone to another by what? Ligament. Okay. So ligaments, tendons all belong to dense type of connective tissue. You see, connection is one important function. Protects. You know, bones are connective tissue, and your bones are protecting your important body organs, right? Your cranial bones are protecting what? The brain. Your heart, lungs are protected by these bones and cartilages, right? So you see, protection is another important function. Bones and cartilages are protecting your internal organs. Support. Your whole body is supported by this, and this whole thing is connective tissue, right? Formed by connective, because all bones are connective tissue, cartilages are connective tissue, right? So this whole structure is basically what? Formed by connective tissue, and it is supporting the whole body. So flexibility. Cartilages of your ear, right? And the cartilage of your tip of the nose. Those are flexible, right? You can change the shape easily, right? Twist it. And when you leave it, it will go back to its actual shape, right? I can change the shape of my ear easily, and it will go back to its actual shape. So elasticity is present in some cartilages. Make sense? And cartilages belong to connective tissue. So elasticity is present in some connective tissue. Transport. We know that the fluid, blood and lymph belong to connective tissue, right? So blood transports the chemicals, right? So another important function of connective tissue, transportation. Three types of fibers I have already mentioned here: collagen, reticular, elastic. Cells. In the connective tissue, we have many different types of cells because many different structures are formed by connective tissue, right? In bone, bone cells are connective tissue cells. Cartilages cells are connective tissue cells. Blood cells are connective tissue cells. Fat cells are connective tissue cells, right? Because all of them belong to connective tissue. So their cells are connective tissue cells. So it's very, high number of different types of connective tissue cells, because we know that different structures are formed by connective tissue. Like in the bone, you have osteocytes, osteoblasts, osteoclasts. In cartilages, you have chondrocytes, chondroblasts. You have fat cells or adipose tissue cells, blood cells, right? All those belong to connective tissue cells. So this is the classification I showed you. Now, let's go over the pictures, how they look under the microscope. Different types of connective tissue. Now this classification will help you a lot. You see here. Oh, I have to erase that. Okay, so first you tell me, look at your note and tell me connective tissue proper. Let's start with that. Connective tissue proper. Loose or dense, right? So loose, how many types? 3. Areolar, right? Reticular, adipose. Remember that? Okay, so this is the first one, loose areola under the microscope. So you see here two types of fibers. The red fibers, they form bundles, and thin dark fibers. These red fibers that form bundles, these are called collagen fibers. Most common type of connective tissue fibers, this one, collagen. Make sense? And the thin hair-like fibers here, those are elastic fibers. So you see, in loose areolar, you see this one and this one. These two types of fibers. Is it clear? Okay. So if you see that, it is areolar. I will mention a couple of areas where you will find that loose areolar is present under the epithelial tissue. Remember I said epithelial tissue gets nutrition and oxygen from underlying connective tissue. That is called lamina propria. Under the epithelial tissue. Always you have seen when I draw the epithelial tissue, I draw this. That epithelial tissue. This is the areolar type connective tissue, and this structure is called lamina propria under the epithelial tissue. So this is loose areola. And also write it down, soft tissue around the blood vessels. Soft tissue around the blood vessels is loose areola. So two locations, repeating again, lamina propria, which is the connective tissue under the epithelial tissue, and around the blood vessels you have loose areola. So two locations I have mentioned. Okay, now let's move forward. Another type of loose is adipose. Adipose is actually fat tissue. Adipose is what? Fat tissue. If you see adipose tissue, in this one the cells are close to each other like this. One thing interesting, in fat cells the nucleus is not in the center. Nucleus is attached to the cell membrane like this. Okay, nucleus is attached to the cell membrane, and inside the cell you have fat droplets. Okay, fat droplets inside the cell. Here you see, what is the nucleus? This is the nucleus here. This one, you see, the nucleus is attached to the cell membrane. Nucleus is attached to the cell membrane, not in the center. Okay. Reticular, another type of loose. So three types of loose, you know, areolar, adipose, and this is the last one, reticular. In reticular, you have this fiber, reticular fibers. Make sense? You have, in reticular, you have what kind of fibers? Reticular fibers. Okay. So in reticular, you have what kind of fibers? Reticular fibers. So these fibers you see here, these fibers are reticular fibers. Make sense? Reticular fibers, just know that where you will find the reticular type of loose connective tissue proper, in lymph organs. Number one, write it down, lymph organs. So reticular is present in reticular type connective tissue is present in lymph organs. Anybody? What are the lymph organs in your body? Very good. Lymph nodes. Anything else? Tonsils. I mentioned it in lymphatic system when I went over those 11 systems. You remember that? I listed this. Spleen. Okay. Also, reticular type connective tissue is present in the bone marrow, and liver. So these are the locations where you have the reticular type of loose connective tissue proper. So now let's go back quickly. How many types of loose? Everybody? Three. This is areola, right? Two types of fibers, collagen and elastic. Make sense? This is what? Adipose or fat, right? Many cells close to each other. Nucleus is in the center or attached to the membrane, right? And fat droplets inside the cell. Stores energy. We know that fat stores what? Energy. Can produce plenty of ATPs. And the last one, reticular. What kind of fibers you have? Reticular fibers. Make sense? So you got all these three types of fibers. These two are present in areolar, this one in reticular. Where you find the reticular tissue, lymph organs, bone marrow, liver. Lymph organs are what? Lymph nodes, tonsils, spleen. Okay? Another one, you write it down, thymus. So all lymph organs and reticular type. Make sense? Okay, so we are done with loose connective tissue proper. Then you have another type of connective tissue proper, that is what? Dense. Where you have the fibers heavily packed, right? Heavily present. So you see here, the fibers, all these are collagen fibers, are heavily packed. So the structure is hard. Make sense? Now, if you see, all the fibers are going in same directions, like you see here. All these are collagen fibers, but direction same. So that is regular or irregular? What do you think?
Regular.
Regular, very good. And if you see that a bundle of fibers going like this, another bundle of fibers like this, that is irregular, right? Because not going in same direction. So this is irregular, this is regular. But both are dense because fibers are heavy. All these are collagen fibers. A common type of connective tissue fibers. Collagen fibers. Dense. This is dense. You see, although the fibers are slightly wavy, but all of them are like wavy. Make sense? So dense, regular, write it down, where you will find tendons and ligaments. Tendons and ligaments. Dense, irregular. You see, this is dense, irregular. Where you will find dense, irregular, write it down. Joint capsules. Joint capsules. Dermis of the skin. Dermis of the skin. That means the inner, under the epidermis. Okay? Uh, yeah, just write down those two structures. There will be a few questions asking where you will find this type of tissue. Okay, like if I ask you that Gardius is formed by what? Dense regular or irregular or what? Irregular, right? Capsule. Irregular. Tendon, ligaments, regular. Sense? Those I mentioned only few locations for each type. You have to remember. If you didn't write it down, then you have to study everything. Okay? I can't help you. Okay? That's why I'm mentioning those. Write it down. 3 types of cartilages you already know from the classification. Most common type is hyalin, and then elastic and fibrocartilage. Let's see how they look like. This is hyalin cartilage. Hyalin cartilage is easy to identify under the microscope. Why? You see here, the cells are located inside lacunae. These are tiny cavities called lacunae. Okay? And the cells are located inside the lacunae. But that is not how you identify the hyalin cartilage. How you identify? These are lacunae. You have the cartilage cells called chondrocytes inside the lacunae. So you can say chondro means cartilage, remember. Osteo means bones. Chondrocyte within lacunae. Lacunae is the cavity here. This is the chondrocyte. And in between lacunae, you have a lot of matrix. So that is hyalin cartilage. You will see a lot of matrix between the lacunae. Make sense? Yes.
So the chondrocyte is that middle layer that we see in the red.
This structure.
Okay, yes.
It is a cell.
The cell.
And inside the cell you have what?
The
Chondrocyte is the cartilage, this cell, okay? And inside you see the dark red, that's the nucleus.
Okay.
You know, the cell has a nucleus, right? Okay. And outside of the cell, this is the cavity actually. Lacunae. It's like this is lacunae, cell is sitting inside. Okay? Chondrocyte. And matrix is plenty, right? Because there is a lot of space between lacunae. Okay? If you see, no fibers, no visible fibers. So that is hyalin. It is the most common type of cartilage I have mentioned already a few times. Most common type of cartilage, right? So most of the cartilages are formed by hyalin cartilage. So let me mention which cartilages. Hyalin cartilage forms fetal skeleton, the whole skeleton of the fetus. Skeleton of what? Fetus. Costal cartilages here. Costal indicates ribs. So these cartilages here are hyalin cartilage. Okay. Respiratory tract, in your trachea, bronchi, you have hyalin cartilage. Respiratory tract. Number 4, joint or articular cartilages. Joint or articular cartilages. Articular means what? Articulation means what?
Connective.
Joint. Another name of joint is articulation. Okay. So if I say joint cartilage, I can also say articular cartilage. Make sense? Okay. So those are the structures, right, formed by hyaline. Fetal skeleton, right, respiratory tract cartilages, then what I said, articular or joint cartilages, right, and attached to the ribs, the costal cartilages. Okay. Then go to next one. This is called elastic cartilage. In case of elastic, so this is hyaline, right? Hyaline. This is hyaline. Now let's see the elastic. Cartilage. Lacunae, again, these are lacunae. Chondrocyte. And elastic fibers. That's why it is elastic. So, make sense? So if you see in between lacunae in the matrix, you have elastic fibers, that is elastic cartilage. Now let's see, go back to hyaline. Here matrix is more or less, lot of matrix, right? Few cells, but most part is matrix. Is it clear? Now let's go to elastic. Matrix is less, right? Because lot of cells are lacunae. Is it clear? And also fibers, elastic fibers are there. So this one has few cells, plenty of matrix, no visible fiber, hyaline. This one more cells, less matrix, and elastic fibers are there. So very simple. And where you will find the elastic, I have already mentioned.
Correct.
Which cartilage? All these are cartilage. So here, right, where you have the elasticity. Nose, right? And another, epiglottis. Epiglottis is the structure inside your larynx. So here, epiglottis. Another structure. I think nose, cross it out. Nose is hyaline cartilage. It belongs to hyaline. So cross out nose. Here, epiglottis and auditory tube. Auditory tube. Auditory tube is also called eustachian. I think CHI. Eustachian tube. I'll check the spelling. Eustachian tube. So another name of auditory is eustachian tube. So you see here, E ear, E epiglottis, E eustachian or auditory tube. Make sense? So all start with E. 3 E's. Elastic cartilage starts with E. Okay? So that's the way you can remember. Elastic cartilage is present in the ear, in the epiglottis and eustachian tube. Okay, so let me check the eustachians. We can check it.
That's
better.
right.
Is that right?
It's correct.
Okay. So, fibrocartilage. You have a lot of collagen fibers. That's why it is called fibro. It has a lot of fibers. Few lacunae and the cell chondrocyte. That's why it is called fibrocartilage. Okay. So if you put side by side and just think, okay, it is not difficult to identify them. You see here, hyaline. Let's go back. Hyaline has a lot of what? Matrix, right? Since a lot of matrix, few cells, chondrocyte in lacuna. Make sense? And no visible fiber. You don't see any fiber. Now let's go to elastic. It's kind of opposite, right? Less matrix, more cells. As well as elastic fibers. That's why it is elasticity. And fibro, its name is telling you, fibro. That means it has plenty of fibers. Make sense? Fibers make the structure very tough. Fibers make the structure what? Tough. So fibrocartilage is very tough. Okay. Example, where you will find fibrocartilage? You will find fibrocartilage in intervertebral disc, intervertebral discs, meniscus, in knee joint, and pubic symphysis. Pubic symphysis. The hip joint, hip bones join here. So fibrocartilage is present in the intervertebral disc. This is called pubic symphysis. This piece of cartilage, two hip bones are joined here. And meniscus in the knee joint. You know meniscus, right? You have heard. It's a torning of meniscus. It happens, right? A lot. It's a breaking of meniscus. So those are the structures formed by fibrocartilages. Okay, so you have learned three types of cartilages. Very good. Bone is also connective tissue. If you see the structure of bone tissue, bone tissue is formed by many columnar structures like this. Look at this. Many columnar structures bundled together. Okay? This is the bone tissue. Each columnar structure is the structural unit of the bone. Make sense? This is the bone. So unit is what? This. So this is called osteon. Structural unit of bone. Structural unit of bone or bone tissue. Make sense? So again, this is what? Whole thing is the bone, right? And structural unit is this. This is called what? Osteon. So many osteons bundled together. Make sense? Now, you see, if I make a cross section of this, cut like this, it will look like this, right? Many round structures, right? Like cross section. So this is how it will look like under the microscope. When I make slice and see under the microscope, it will look like this. Is it clear? So let's do that. Each round is what? One osteon. Make sense? So this is one osteon, this is another, this is another. In the center of the osteon, you have a canal. That is called central canal. Okay? Why you have a canal in the center? Blood vessels, artery, vein, and nerve. So nerve and blood vessels. Blood, right? And nerves. We know that bones are vascular, bones are blood vessels located there. Around the central canal you have lacunae, again lacunae, tiny cavities like this. And inside the lacunae you have the osteocyte. Osteocyte are bone cell. Osteo means bone, cyte means cell. So lacunae contain osteocyte. Osteocyte in lacunae. Makes sense, right? Osteocyte sitting inside the lacunae. Okay? So that is another thing. And in between the lacunae, you already know, in between the lacunae you have what? You remember when we talked about the cartilage, in between lacunae? Matrix. Very good. Make sense? So this is the matrix of the bone. And that matrix, you tell me, this is very simple. Matrix of the bone is hard or soft? Hard, very hard. Make sense? That gives the, hardness of the bone. So this hard matrix of the bone between the lacunae is called lamella. Lamella is the hard matrix of the bone. The last thing is central canal is connected to lacunae by very fine channels, thin like hair-like fine channels. Those are called canaliculae. And also one lacuna is connected to another. The lacunae are connected to each other by those fine channels like this, and these fine channels are called canaliculi. Canaliculi or canaliculi. Let's see here. This is one osteum, this is another osteum, this is another osteum. This is the central canal, contains the blood vessels and nerves. These are the osteocytes. You see the dark cells, these are osteocytes. They are actually located inside the lacunae. It's not very clear in this picture. And then you see the fine thread-like channels. These are called canaliculi. So the fluid containing nutrients and oxygen can go from one lacunae to another, because inside the lacunae you have the cells. Those are alive and you need to give them nutrition and oxygen. So canaliculi are the channels. Take the nutrients and oxygen from one lacunae to another and from central canal to the lacunae to keep the cells alive. Okay? So that is the structure of bone tissue. Is it clear? So this is the whole thing is the bone, right? And structural unit is a columnar structure. This is called what? Osteum. Many osteons together form the bone tissue, right? And this is the structure of each osteon as a central canal, lacunae containing the osteocyte, and hard matrix in between lacunae called the lamella. Okay? And fine channels are called canaliculi. Okay. Blood. Blood is also a connective tissue, but it is a different type of connective tissue, different than others. Why? how it is different than others? It's liquid, right? And it circulates, it moves, right? It's the fluid form of connective tissue. You learn about blood in LP2, just know that blood belongs to connective tissue, right? And one more thing you can know here, blood has cells, and plasma is the liquid like matrix in between the cells. So these are the cells, and the liquid in between the cells, it is like the matrix of other connective tissue is the plasma. Okay. There are different types of blood cells, right? Red blood cells, white blood cells, you know that already. Platelets. Okay. So that is the blood. Okay.